Each number in a fraction has a name. Each number in a fraction has a name. On the top, the numerator, down below, denominator. Each number in a fraction has a name. So we have been talking about fractions, and your April number corner is fractions. So you're going to be doing a math lesson with fractions, and I want to show you your number corner pieces. So this first number corner piece is a garden, and I don't know how many people are starting to plant their gardens yet, but this particular garden piece has a division this direction and this direction. I can plant 4 different vegetables inside this garden. Oliver, what's a vegetable you would put inside your garden?
Broccoli.
Broccoli. Clara, what would you plant?
Lettuce.
Lettuce. And Ian, what would you plant?
Carrots.
Carrots. What about you, William?
Probably basil.
Well, I notice that I say this is the whole garden. And I notice that in this whole garden, it's divided into how many different sections that we could plant? 4. So I say that each of these sections is 1/4. What is each piece of this?
1/4.
If William got to plant something in his section, and I added it to Clara's section, how many sections would that be?
2/4.
1/4 plus 1/4 is 2/4. What number changed?
The top. The top.
The top. What number didn't change?
The bottom.
When I add fractions, my denominator doesn't always change, except there's one thing. 2/4 is these two right here.
It's 1/2.
Wait a minute. 2/4 is the same as
1/2.
1/2. We learned that if the top number
So
is
basically
half of the
whatever
bottom number, or
denominator-
if you can
So
add the top
basically
number.
Mommy, basically.
Go ahead.
Basically, whatever is half of the denominator on the bottom is half of the number.
Yes. So if you can add the number on top, 2 plus 2 equals 4, then that is equivalent to 1/2. So even though I don't change the denominator when I add those, 2/4 is equal to 1/2. Now I want to look at our next piece in our number corner. Now wait a minute. Our next piece is the same size garden bed. So I have a whole garden bed. But how many people can plant vegetables or fruits in this garden? 3. What changed? My numerator or my denominator?
Denominator.
My denominator changed. Since there's 3 pieces on the bottom, I call this 1/3. And if I added all 3 pieces together, 1/3 plus 1/3 plus 1/3, what is 1 plus 1 plus 1?
3.
3. When I add those 3 pieces together, do I change how big the pieces are? The denominator stays the same. Now wait a minute, but 3/3 is equal to something. In a fraction, if the top and the bottom are exactly the same, that is 1. It's just the number 1. It's the whole garden. There's 3 pieces, and if you plant fruits or vegetables in all 3, that's the whole garden. Let's look at our next one. Oh wait, we have another whole garden here. Ian, how many pieces are in this garden? 2. Ian, what changed? The numerator or the denominator? The denominator changed again. If I have 2 pieces in the garden, then that's called 1/2. If I have 2 pieces and I have one person plant on one side and another plant on the other side, what's 1 plus 1? 2. If I have 2 halves, if the numerator and the denominator are the same, that is equal to 1 whole. Let's look at one more piece here.
That's 1 whole.
Wait a minute. That garden has no spots split up.
It's 1 whole.
That is just 1 whole garden. You could plant the whole garden with whatever fruit or vegetable you choose. I think I would pick, ooh, that's a tough one for me. Carrots. Yum. I love to have carrots with my dinner.
Strawberry.
The last time we looked at our fractions, we looked at a garden that was split into different amounts, or the denominator changed. Today we're going to look at some of the fruits that come out of this garden. And I have a plate of fruit right here that has what on top of it?
Strawberries.
How many strawberries are on that plate?
5.
5. Instead of calling this a whole plate, I call this a set. And a set is when I have a group of something, and If all of them are strawberries, then I would say my denominator is 5 because there are 5 pieces of fruit. If all 5 are strawberries, I could say 5/5 are red. So hold on, let's look at this next one. Tell me an observation that you notice about that set of fruits.
There's 4 strawberries and 1 blueberry.
There's 4 strawberries and 1 blueberry. So I would say 4/5 are red. Can you tell me a fraction that would tell how many are blue?
1/5.
Ah, what is 4/5 plus 1/5? What is
5/5.
strawberries plus blueberries?
6.
Well, 4 strawberries plus 1 blueberry is 5.
It's 5. It's a whole.
5/5, and if the numerator and the denominator are the same, that is 1 whole. What do you think is going to be on this next piece?
I don't know. 2 blueberries and 3 strawberries.
You think 2 blueberries and 3 strawberries. Do you think something different? You think the same as him? Let's
Yeah.
see if you're right. You were correct. Oliver, can you tell me the fraction that are red?
3/5.
3/5. Notice that my denominator is not 2 blueberries. It's not 3 twos or 3 halves. It's 3/5. 3 are strawberries and there's 5 altogether. Ian, can you tell me the fraction that are blueberries?
2/5.
2/5 are blueberries. 3/5 plus 2/5 is 5/5, which is the whole set. Let's look again. Was that what you thought was going to happen?
Yes.
How many of those are strawberries?
2/5.
2/5. The denominator is not changing. In our first group, the denominator changed in every picture, but in this grouping, the denominator does not change. What do you think is going to be on this last picture?
4 blueberries and 1 strawberry.
Oliver, do you agree or disagree? Agree?
Yes.
And you were correct. So this last one is 4/5 are blue. What could you say is the adding sentence for that last one?
4/5 plus 1/5 equals
4/5 plus 1/5 equals
5.
5/5. If the top and the bottom are the same, what do we call that?
1 whole.
1
Since
whole.
these all have the same amount of numbers, they'll always equal 1 whole.
They'll always equal 1 whole.